Hi, in this section we're going to be talking about trapezoids and kites. So let's start with trapezoids. The definition of a trapezoid is that it is a quadrilateral with exactly one pair of parallel sides. And that word exactly is very meaningful here because it says there's got to be one pair of sides that are parallel, but only one pair of sides that are parallel. Now, those two parallel sides are called the bases, and you can see here in the diagram, those are the bases. They are parallel to each other. The non-parallel sides are called the legs. The legs here, all highlighted in green, is this one and this one. Now, there are two pairs of base angles that are formed by one base and the legs. So for example, this and this, A and B, are base angles. They're formed by a base and a leg. And also this D and C are formed by one base and one leg. Those are base angles. Okay? All right. Now, an isosceles trapezoid is a special type of trapezoid. And the definition of that is that it's a trapezoid with congruent legs. So as you know, these are the bases, okay? Those are parallel to each other. And now the two legs, this one and this one, are congruent to each other. Okay, now let's talk about some of the theorems for isosceles trapezoid. The first one is, if you have an isosceles trapezoid, then each pair of base angles are congruent. So for example, the premise is, if these two are congruent to each other, and of course this has to be a trapezoid. If the two legs are congruent to each other, then this pair of base angles is congruent and this pair of base angles is congruent. Okay. Next, it's the converse of this one, which says if each pair of base angles are congruent, then the trapezoid is an isosceles. So for example, if this and this are congruent to each other, then these bases are congruent. The legs are congruent to each other. So this is the converse of the one above. Next, the diagonals of an isosceles trapezoid. So if you have an isosceles trapezoid, the diagonals are congruent. Okay, so here's one diagonal, here's another diagonal. They're congruent to each other, so that means this plus this is equal to this plus this. Okay, now here we come across this symbol right here. This is a double-sided arrow. That double-sided arrow means both the conditional and the converse are true. That means I can say if you have an isosceles trapezoid, then the diagonals are congruent, or I can also say if the diagonals of a trapezoid are congruent, then the trapezoid is isosceles. Okay, let's move on. Suppose you have EFGH as an isosceles trapezoid with bases EF and GH. Okay, so first I want to draw that. Okay, an isosceles trapezoid, EFGH, and I start labeling one side, one vertex, EF, that's a base, and then just go around clockwise, GH. So EF and GH are bases. That means they're parallel to each other. Find the measure of each base angle if E is 7x and G is 16x minus 4. Okay, so if E is 7x, well, I know that these two base angles are congruent to each other, so that's also 7x. And I know that these two angles are congruent to each other, so that's also 16x minus 4. That means you can do this two ways. One is you can say 2 times 7x plus 2 times 16x minus 4 is 360, because in a quadrilateral, all the angles add up to 360. But also, since you have 2 of everything, you can also say 7x plus 16x minus 4 is 180. Both are equally fine. So we get 23x is equal to 184, and x is equal to 8. Okay, next. Let's talk about the median of a trapezoid. Okay, the median is a segment that joins the midpoints of the legs of the trapezoid. That means you take a trapezoid, you take one of the legs, and you find the midpoint. Now you go to the other leg and you find the midpoint. And what you have to do is you have to connect those 2 midpoints, and what you have, that green line, is a midpoint. I'm sorry, is a median. It's a median. It connects the 2 midpoints. And the thing about a median is it is parallel to the bases of the trapezoid. All right, so all these 3 are parallel to each other. Now, that's not all about medians of a trapezoid. It turns out the median of a trapezoid has a theorem of its own, and the theorem says that the median of a trapezoid is not only parallel to the bases, but its measure is 1/2 the sum of the measures of the bases. In other words, it's the average of the base lengths. Okay, so this is a median right here. Okay, that's median EF. Its measure is 1/2 of the length of AB plus the length of DC. Okay, another way to write that is EF is AB plus DC over 2. And honestly, it's just preference, how you want to do it. Some people like that version, some people like that version. It's all the same to me. Okay, so let's take a look at some of these problems. If AB is 10 and DC is 18, so those are the 2 bases, we want to find EF, the median. Well, EF is 1/2 of 10 plus 18. EF is 1/2 of 28. So that's 14. Next, let me reset my diagram here. Oh, I can't erase for some reason. Oh, okay. That's fine. So we'll say AB is 15, EF is 20, and I want to find DC. Okay. Well, the median, 20, is equal to, this time I want to write it the other way, 20 is equal to 15 plus DC, okay, over 2. Multiplying by 2, 40 is equal to 15 plus the length of DC, so the length of DC is equal to 25. Okay, moving along. Again, I have EFGH is an isosceles trapezoid with EF and GH as the bases, so EFGH. And it has median YZ. Okay, so if I want to draw the median, that's just a line right now. That's not a median. In order to make sure that I say it's a median, I need to show that the sides are, that the median connects the 2 midpoints. And now this is YZ. All right, so EF is 3x plus 8. GH is 4x minus 10. YZ is 13, and I want to find x. So the median is equal to 3x plus 8 plus 4x minus 10 all over 2. All right, so what I get here is 13 is equal to 7x minus 2 over 2. Multiply both sides by 2. I get 26 is equal to 7x minus 2. 28 is 7x. X is 4. And there we have it. Okay, next. Let's move on to a kite. All right, this is completely different now. A kite is also a quadrilateral with exactly two pairs of consecutive congruent sides. So for example, I know when we draw a kite, you know, like a kite that you want to fly, that's the shape that we draw. Well, the thing is, it has two pairs of consecutive congruent sides. That means this one is congruent to its consecutive side, the one right over. This one is congruent to its consecutive side. And again, both of those pairs have to be congruent to each other, the reds and the blues. That's a kite. Okay, let's talk about some theorems for a kite. If a quadrilateral is a kite, then the diagonals are perpendicular. Okay, so now that's so much to, get straight right now, right? So we have the diagonals here are perpendicular, the diagonals of a trapezoid are congruent, and then we've got, different situations for a rhombus and a rectangle. So it's very important that those flashcards are ready to go and you're studying them daily. Next, if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Exactly one pair of opposite angles is congruent, okay? Now, it's always the same pair that's congruent to each other. And how do you find the pair that's congruent to each other? Well, look at this kite right here. You have JK and you have JM. Do you see how JK and JM, those two sides are not congruent to each other? It's the angle in between those two sides and right here as well, right? So it has to be the angle between the non-congruent sides, okay, is congruent, all right? So the angles between the non-congruent sides are congruent. That's important. Okay, all right, let's do it. So in the one that I drew right up here, okay, the angles that would be congruent is this one here and this one here. Okay, let's move on here. WXYZ is a kite. We need to find the measure of XYZ. We need to find the measure of this one. Okay, fine. So now, I know that 121, that's between the two sides that are not congruent, is congruent to this one, Z, 121. Okay, that one is angle Y. Okay, but this is a quadrilateral. That means all four angles add up to 360. So I say 2 times 121 plus 73 plus measure of angle Y is 360. And then if you solve it out, you get that measure of angle Y is equal to 45 degrees. Okay, so you see very, very clearly that these two are not congruent to each other, and they should not be congruent to each other, because that's what the theorem says. If those two that I highlighted in red, if those were also congruent to each other, then you would have two pairs of congruent sides, and that would no longer be a kite. That would now, be more of a parallelogram or possibly a rhombus or something else. Okay. All right. Next. MNPQ is a kite. You need to find NP. We need to find this side right here. Okay, so what information are we given here? We're given information about the diagonals. Okay, so what do I know about the diagonals of a kite? I know that they are congruent to each other. So if NP has a measure of X, then so does MN. That also has a measure of X. Now, if I highlight that triangle, I have a right triangle with sides 6, 8, and X. I can use the Pythagorean theorem there. Okay, so 36 plus 64 is X squared, and 100 is X squared. Take a square root, x is plus or minus 10. But since x itself represents one of the sides, it cannot be a negative number. So I just say NP is equal to positive 10. Okay, and there we have it. Thank you very much.